Welcome, everyone.
The most important reason to fund this conference was so that we could all get to play with Sandy's toys. So every time I've ever been asked to give welcome to IQSS, I've turned them down every single time except for this one, because I think this is not only a particular emerging field, as David says. I think this is basically the future of the social sciences. I think this is what the social sciences is going to be. It's going to be lots of other fields as well, including Sandy's. But I think that this is really what it's about. So welcome to IQSS, and welcome to Harvard, and welcome to America, and anywhere else you'd like to be welcome to. I think it's our job to preach to the choir. Thank you for arriving. So why is it that I think that this is the future of the social sciences rather than just another neat, new, cool field? When university administrators look at the university, they think of the sciences and the social sciences and the humanities. And, well, we could put the humanities to the side. They ask all the great questions. They were asking all the great questions 2,500 years ago. They are asking the same questions now, and they're going to be asking the same questions 2,500 years from now. It's very important, and they'll keep doing it. If you look to the sciences, that's where all the really cool discoveries get made, right? They cure diseases. They discover how old the universe is. They realize that they need to ask the question how old the universe is. It's absolutely spectacular change. If you look at the social sciences and you ask what they are. And in fact, if you ask the best social scientists what they do, you know what they say? They say, we study this. And if you say, what's the social sciences going to be? They say, we used to study this, and now we're going to study this. And then we're going to study this. And so there's a lot of studying going on, and that's really terrific. But that's not like the sciences, right? And so what's the story here? Well, part of the story is the funding in the sciences is so massively different than the funding in the social sciences that you shouldn't expect us to have accomplished anything. And so the next logical question is, okay, so if we gave you some more money, why would it be any different? Why wouldn't you just be studying some more things? So the answer is data. Right? The amount of information that we are getting and are about to get on the social and political and economic worlds is massively changing. Okay? So for the last 50 years, for the last half century, the information base of the social sciences was primarily three things. It was survey research, it was end-of-year government statistics, and it was one-off in-depth studies of particular places, events, or people. Okay? About half of the quantitative work done half of the quantitative work done in political science, to pick one example, is survey research. Okay? Now, that's probably the most important methodological innovation in measuring human beings in the last century, certainly. We've learned an incredible amount, but if you think about what it is, it's random selections of isolated people from unknown geographic locations, right? Because we're not usually allowed to know who they are. Their names are stripped before we get them. And we're not usually allowed to know where they are, right? And at best, we can call them up once a year, maybe. You know, from political science, we call them up every time there's an election, right? Usually not the same people, but maybe the same people every 2 years, and we ask them what's going on. Okay? So survey research, end-of-year government statistics, one-off in-depth studies. Okay? So in the next half century, it's perfectly obvious that will continue. We'll still do lots of those things, but we know that there's a few other information sources. At least if we pay attention to what everybody here is doing. There's also a problem with those three sources. So survey research is the scientific foundation for survey research is pretty much crumbling. It's no longer possible to do anything remotely resembling a random sample. I mean, are you going to pay for an hour call on your cell phone when someone has randomly chosen you? It just doesn't happen anymore. And so those things need to be fixed. End-of-year aggregate government statistics or end-of-period government statistics they're great. There's an enormous amount of data, but in a lot of places they have dubious validity, intentionally crippled resolution, political constraints on what kind of information can be provided. So where are we going? So let me give you a summary. I'm happy that I'm in the group that's going first, because I hope this will be obvious later on. The information base is just going to completely change. So we're going to have, for example, continuous time information on almost everything. We're going to have text sources. So I have a project right now where in the building across the street, we're downloading all English language blog posts every day in continuous time. And you know what? Once you figured out it was hard to figure out how to do it, but once we figured out how to do it, it's not that big a deal. I mean, it doesn't even take that much in the way of computer resources. There's 100 million blogs worldwide, right? They don't all write all the time. And it's true, no one's reading them. But in any event, there is a characteristic of human beings that they like to express themselves, even if nobody's paying attention. Even if people are reading the nice reading material they gave so that you could read while I was speaking. But people like to express themselves, and this new technology of blogs has made it possible to capture that instinct of people and let them express themselves. And for researchers, it's all there on the web. So that's just one little thing. Okay. In addition, of course, there's speeches by politicians. There's government reports. There's an enormous amount of information on the web. If you take electoral activity as a second category. So it used to be we would get who would win and how many votes they would get. So now we get ballot images. So for each person, we don't know who the person is, but we know the string of votes they made on the 20 different offices and referenda they voted for. We have precinct-level election results, geographically pegged, of course. We have individual-level registration. We have primary participation. We have campaign contribution data. I have a data set where I know every single person in a few states. I know their name, social security number, age, the last 20 elections they voted in, whether they voted in the Democratic or Republican primary. I geocoded their location. I know exactly where they are. I know exactly where the voting booth is. Compare that to calling somebody up and just asking them, to tell us some things. Please, would they please tell us some things if they remember them, right? There's commercial activity, right? So I was in Iceland 3 years ago and bought something at a gas station, and within 30 seconds, my credit card company calls me to ask me whether it was really me, right, on my cell phone, right? They have that information. We need that information, okay? Okay? There's geographic location, which Sandy showed you these really cool things, cell phones, fast lane transponders, things like that. There's health information. They hold on to it most tightly, but there's digital medical records, hospital admittances. I like that in cell phones now. Not only are there GPS receivers and other kinds of location information, but they're putting accelerometers into the phone, right? And the application is so you can play tic-tac-toe with your hand, right? That's a good application, okay? But we have plenty of people who are trying to measure exercise, right? So you measure exercise, you ask people, well, how many times were you on the treadmill last week? If they tell you, if they know, if they can possibly quantify how hard they were working on the treadmill, that's not most of the exercise they were doing. It's whether they're sitting still or they're jumping up and down like I'm doing now, right? But if we can track exactly how much movement they have without having to ask them any questions, that's a tremendous, that can be a tremendous contribution. Then we have the biological sciences, which are becoming essentially part of the social sciences, right? What are they doing? They are tremendous data collection machines, right? And the unit of analysis is effectively becoming the person, right? They have not too many people, and they have 3 billion base pairs, and that's only genomics. And then they have proteomics and metabolomics and all kinds of other omics, and brain imaging and all kinds of things. They're person-level analysis, which is essentially social science. That's sort of what we do. That doesn't include satellite imagery, where we can measure all kinds of things. The internet is spawning social networking sites, social bookmarking, comments on blogs, blogs that link to other blogs, virtual worlds. Still half of what we do when we publish articles in the social sciences is survey research, right? That's still, okay. All right, so I noticed the person over to my left who's responsible for Harvard's IRB, so I'll just mention that, that I always check everything in with him. And it's true, anybody that hasn't been briefed by this group, it gets very scared about privacy. And privacy concerns are really important. But you know what? Over in the medical school, they randomly assign you to take a drug that we don't know whether it's going to help or hurt you, or have your chest opened up and do some operation where we also don't know whether it's going to help or hurt you. And they somehow manage to do that. And Dean can help us deal with this. Okay, it's not an easy problem, but it is totally deal withable. So it shouldn't scare you away. And that's just things that we ought to be able to go out and get. But then there's the transformation in society from things that are analog to things that are digital. And when those things become digital, it just turns out that they also spew out data. Okay, not only do they make it possible to make things lighter and easier to carry and more efficient, and they do cooler things, and therefore you'll pay more money for them, and we can extract more money from you and stuff like that. But actually, they also spew out data, and they make it possible for us to get much more information on lots of different things. So that's just another little thing that's happening in the world. Another very interesting thing is that governments are systematizing their records. This is an enormous change in society. So governments, which is, constitute a large fraction of what goes on in the economic world, are taking their bureaucracies and they're moving from paper to electronic records in all kinds of ways. They're putting stuff on the web. They're making things available. They're letting researchers run randomized experiments all over the place. We have a randomized experiment that we're completing. We've completed. In fact, we're sitting in my office writing up the results at the moment. And this is we randomly assigned 500,000 people in Mexico to have health insurance or not, and health insurance, and also hospitals and doctors and pharmaceuticals and preventative care and all kinds of other things. It's the largest randomized health policy experiment I think ever, and it never would have been possible without lots of the kinds of things that we're talking about now, and without the realization from government officials that they could actually learn from the kind of stuff that we're doing. So instead of trying to extract, as a political scientist, information from a few thousand people that will randomly call up on a phone and ask about, let's say, political activism, we can and we actually do analyze the tens of millions of people that post information on the internet. There's tons of examples like this. So we have to tackle the privacy issues. We have to tackle the informatics challenges, because if you download the data one way, it's not, if the idea about how you get all this in all the blogs, just to take an example, is, well, you get a list of all the blogs. Okay, now you can't do that, but let's suppose you could, and then you just write a loop, right? Go to the first site, get the information, put it in the database. Go to the second site, right? Send out a request, get the if you did that, it would take forever to get even the first list, right? Because when you click on something, it takes a while. So there's all kinds of stuff that, as social scientists, we don't know how to do. We're not computer scientists, right? So we have to figure out. Well, okay, so there's 10 million things in this list. So actually, it turns out you can send out a million at a time, and then you can create all these threats. And so we have to learn about all this stuff from these other fields. Then there's our field. Or my field, which is statistical methods. Nobody knows how to analyze data like this. So the blog example I mentioned, we came up with a statistical method of analyzing those data. But tracking people with cell phones, where the database, the unit of analysis is basically a curve on a map, a trace on a map of where you went. There's no statistical methods to analyze anything like that. And that's just one example. All the other examples I could say basically the same thing about. We know that we can create these methods. We know it is possible, but we have to do it. So there's lots of things to do, and it's perfectly clear that even 10 years, but certainly another half century from now, when we all come back here and hobble in, or float in, that the moment in history that's defined by roughly now, it is an enormous change in the way social sciences go about doing their work, and the change will continue. But it really is this time where we go from random selections of isolated individuals from unknown geographic locations occasionally to continuous time information on people will make it possible to learn far more about society and to eventually start actually solving the major problems that affect the well-being of human populations. So I'd like to hear from Nicholas.
Welcome, everyone. Okay, so I'm going to give you a bit of a perspective, again, from my own parochial interests. I was asked to comment a little bit on what I perceive to be some of the big problems in social science and coping with data complexity. When I saw the nature of the audience, I realized that many of the things I might want to say would be apparent to many of you. Nevertheless, I hope the remarks I might make might be somewhat synthetic and that I might give some examples from, again, my own particular perspective on what I see to be the problems and the promise of some of the methods and data that we have to bring to bear on some of the problems that Gary just outlined. Now, I want to acknowledge my collaborator in much of the work on social networks that I do, who is James Fowler, who's sitting in the back, and I'm going to be presenting some other work that I've done in collaboration with Kevin Lewis and Jason Kaufman, and also with Laszlo Barabashi, who's also sitting here. Now, so in discussing some of these big problems on social science and computation, I want to focus on social networks, but many of the problems and computational challenges that we face are faced in other types of data and other kinds of work that people are doing. And most generally, my own research group is interested in how illness and healthcare use and disability and death in one person can spread and cause illness and healthcare use and disability and death and health behaviors in other people to whom the first person is connected. How can we get a kind of non-biological spread of disease, a kind of sociological spread of disease? How can we track it in real time? How can we look at it in tiny units of analysis, whether they're minutes or days or individual people, and so, or particular diseases or particular kinds of interactions, and so forth? Now, our first example looking at this was the spread of obesity in social networks. So it had become very trendy to speak about obesity being an epidemic. And James and I began to wonder whether, in fact, obesity really did exhibit epidemic properties. Was there a sense in which weight gain in one person could be transmitted to other people to whom a person is connected? So we assembled a data set of about 12,000 people using a very well-known study known as the Framingham Heart Study. These were individuals who had been followed for 32 years and had come in to be weighed every 4 years. And we used archived paper records, nothing like what we could do in the future. We had to retrieve these paper records, manually key them into a database, and reconstruct the social network ties of the individuals across this period of time. And having done so, we can show some animations like the one I'm about to show you. This animation here shows individuals, of course, are nodes, and we make the size of the node proportional to the person's BMI. So fatter people get bigger nodes. And then the perimeter of the node indicates the gender of the person. So this is beginning to get a feel for the covariate complexity of the data. So the red perimeter nodes are women, and the blue perimeter nodes are men. Then we can also index the nature of the ties between people. Gray ties indicate spousal ties. So this woman, obese woman, is married to this non-obese man. And then the purple ties indicate friendship ties. So this man, this is this other man's close friend over here. So what we're going to do now in a moment is we're going to put the network into motion. We're going to take daily cuts through this network for 32 years. And we're going to watch as people gain weight or lose weight. People can be born into the network or die and drop away. Ties can form and disappear, so the topology will change across time. And our objective here is to see, can we trace a spread of obesity within the network? Can we see as one person gains weight, do others gain weight? there's a woman up towards the top there, I don't have a pointer, who's going to gain weight in a minute and move to the center of the network. There she goes. There she goes. Sort of causing obesity everywhere around her. She just moves right to the center of the network.
Just because of gravity?
Yeah. So that is the sort of one visual rendition of the kind of work we're interested in. When we first started doing this work, our fantasy was the following, borrowing some ideas from physics. I thought it would be possible for us to imagine a certain person gaining weight, and then as this person gained weight, to watch a kind of wave of obesity spread out from around them, spreading from this individual person, causing weight gain in first-degree removed alters, then second-degree, third-degree, and so forth. In a kind of like dropping a pebble in a still pond, you get these waves that spread out from the pebble, these concentric circles. They might hit the perimeter, bounce back, and you could get interference patterns. And we imagine that you might have these kind of peaks and valleys of obesity and thinness within a kind of socio-topological space. And our hope had been, through the reconstruction of this network, with the data that we had available to us, that we could see these peaks and valleys. So that we could see this person gain weight and then it kind of bloom around them. Incidentally, we're not just looking at weight gain, we're looking at many behaviors. Some new work we've done, we're looking at happiness, and we can see the spread of happiness in the network. I get happy, it makes Gary get happy, and it makes Sandy get miserable. Spreading from person to person. Anyway, but what we found when we did this kind of visualization I just showed you is that we didn't see this. We didn't see this kind of spreading out. And the reason, of course, is that obesity is not a unicentric epidemic. It's a multicentric epidemic. So it's like not throwing a pebble in the pond, but a whole handful of gravel into the pond. So you get these complex interference patterns, these kind of choppy surface, so it's very hard to discern what's going on. And this then in turn requires the invention of a variety of new methods that allow you to find the signal in the noise, discern what's really going on, and recover the plunk of a single pebble. So things in this kind of world that I just described to you can be very complicated. We have multiple nodes. Behind each node is a covariate vector that describes the attributes of the node, their BMI, their gender, and a whole host of other things. The topology can be complicated, and all of that can change across time. And in fact, it can get more complicated still. This is our maps. I apologize for the quality of the image. This shows the location of the participants in our study in Framingham and adjoining towns. On the left-hand side, we co-mapped their geographic location and put green lines that connect friendship ties. So if two people are friends, we draw a green line between them. And on the right, we have sibling ties. Again, a very high level of social and geographical complexity, which we're trying, first of all, to visualize, and secondarily, to analyze. Now, this illustrates a broader set of topics that are being engaged by social scientists because of the explosion in geocoding and geo-tracking technologies, which Gary's already alluded to, and many of you are no doubt familiar. But one could generalize still further and create a two-node networks, for example, mapping restaurants in space according to their sharing of clients, which we're beginning to do with our data, mapping the location of all these restaurants. I wish we had the cell phone data so we could see who was at the restaurant when and track them across time and in space and in motion. And one can begin to test claims, such as our claim, that the placement in social space is or is not more important than placement in geographic space. When does it matter more where you are, and when does it matter more who you know? And can we, in real time, ascertain these kinds of properties about large groups of people at the same time? Now, there has, of course, been an explosion in the scale of social network studies made possible by the by communication technologies and by what I call massive passive data acquisition. So one of the classic studies, which I put there first, was published by an anthropologist by the name of Zachary on the Karate Club, the very famous Karate Club data set. It involved 34 people. There was a fissioning of the club between two club leaders. He had very static information about these people. And since then, there's just been an incredible explosion. In 2003, this 436-node network of email exchanges over 3 months at a corporate lab, 43,553 node network of email exchanges over 2 years, Kosinitz and Nets in 2006. Not to be, I've done more, 4.4 million node network of declared friendships in the live journal blogging community, 4.6 million node network of phone users in Europe that Barabashi and his colleagues have done. You'll hear more about that later today. 240 million node network of all IMs over 1 month in MS Instant Messenger, and then whatever Gary is working on at the moment, which will be bigger than anything else on the page. So Zachary's study was illustrative of the classic studies. It was limited in the size of the network, in the number of discernible ties, in its longitudinality, and in our ability to resolve what's actually going on between the individuals involved. And the new data that is available is making it possible, on the other hand, to see more of the world, see properties not previously discernible, and to study rare events, for example, like suicide, which is of great interest but is difficult to discern if you have small samples. Now, on the other hand, the links may be sociologically meaningless, these links that we find, or methodologically intractable. What does it mean, for example, to have 1,000 Facebook friends? Is there any sense in which these are really, sociologically speaking, meaningful friends that you might have? Or what does it mean to exchange a single IM message with someone else out of 240 million nodes exchanging messages? These questions are prompting a variety of conceptual and methodologic innovations, including moving to weighted networks. So now we start imagining that the network ties are not binary, but rather are weighted, and now you can represent the connection between every node to every other node, which affords certain methodologic advances. There was a paper in the August Journal of Econometrics on using weighted networks as instruments in a certain kind of clever way. It affords us opportunities when we do this to make both methodologic and conceptual advantages. Now, are there in fact new rules for social interactions? Do genes still matter? Does intimacy still matter? And does geography still matter? Well, even in this world, it turns out that geography still appears to matter. This was a study that was published in PNAS of 500,000 live journal users, and it shows that friendship decays with distance. Here on the left is a probability that any two individuals will be friends, and here is the distance between them in kilometers. And you can see a kind of linear distribution here, even in this virtual world, in which in principle it's possible to befriend anyone else. Still, there's a fundamental constraint of geography on these kinds of interactions. So adding geographic details to all the other topological, covariate, and temporal detail gives us still more purchase on what is going on, socially speaking. But think of the complexity of the data here. All of these things can be changing across time, and in and of themselves are quite complicated. Now, our own work occupies a kind of middle ground space, the work that I do in my group, of networks that typically have 4-digit size or 5-digit size. 1 to 20,000 people are the kinds of sizes that we've been studying. But even here, in this kind of size, things can get much more complicated even than what I've just been discussing, because the ties themselves between the nodes on the network can become complicated, can become multiplex. For example, this is some work done with Jason Kaufman and Kevin Lewis. This just shows one of our current data sets, this Facebook network data set, which will soon become a public use file, subject to certain provisions, archived at IQSS. This just shows for a single dorm at an elite Northeastern university, 104 individuals who are connected and are close friends. They appear in photographs together on Facebook. Now, and the average number of such friends they have is 6.6, the kind of more socially tractable, kind of conventional understanding of what it means to have a friend. But in addition to being friends, they could also share membership in an ethnic club. They could be members of a club, and that could also be used to form ties. Some of these individuals might not be friends with each other, but nevertheless might belong to the same club. Or they could also be roommates. Some people are not friends with their roommates, so there's no tie between them. But you can discern a roommate tie between them. Or they could be Facebook friends, which is a kind of very lax standard for friendship, because the average Harvard undergraduate in 2006 had 106 Facebook friends. And so you can plot all these ties simultaneously in this way, and each of those ties is a different kind of a tie. And then, of course, one can expand to include the whole network, not just a single dormitory. These are 1,700 people at this college, with all the 4 different kinds of ties that I've shown so far mapped simultaneously on the network. And, of course, we are following these over time and watching how it evolves. Now, returning to the idea that things can spread on networks, going back to the example of obesity that I alluded to earlier, can we add even further level of complexity by looking at this process of diffusion? And can we take it to the next level beyond what James Coleman did in the 1960s, looking at the diffusion of antibiotic use amongst a group of North Carolina doctors, a very famous example of the diffusion through networks? Well, here is an example. There's someone called Justin Timberlake. I don't know who this is. And he was listed as a favorite artist for a number of students in this network, and the ones that listed Justin Timberlake as a favorite artist are marked in red in this network. And if you look a year later, you can see that more people like Justin Timberlake, and it's possible to discern the diffusion of a taste for Justin Timberlake through the network and begin to examine, do people adopt the tastes of other people to whom they are connected? And here we're just talking about the trivial thing like Justin Timberlake, but of course we could be interested in much more important things. For instance, the spread of health-related behaviors, financial transactions, and other kinds of things as well. But one of the kinds of things that could be highly relevant is a taste for privacy. And we have been doing some work looking at privacy settings on Facebook. This is an object of inquiry, but it's also of fundamental relevance to the topic we're discussing today. Here in red, we highlight those individuals who in 2006 had privacy settings set on their Facebook profiles that prohibited, for example, faculty from seeing what was on their profile, but would allow other individuals. And here it's what it's like a year later.
But not all faculty.
Not all faculty. No, well, actually, we have different kinds of ways of getting this data. So this is before, and this is after, right? So a kind of a spread and a taste for privacy on the network. And some work that we've done analyzing it, and that's forthcoming, we show that actually this taste for privacy diffuses, and that you're more likely to adopt privacy settings if people to whom you're connected adopt privacy settings, just like you're more likely to pick Justin Timberlake, or you're more likely to gain weight. Now, many of the things we might be interested in might in fact diffuse, and of course, not just obesity or taste for Timberlake or for privacy. These could include things like financial services or banking behaviors. This is not just the example of like the adoption of fax machines, where as more people adopt the fax machine, it becomes more useful, in the example that Damon Centilla often gives. But also it relates to the fact that there could be now a diffusion in the adoption of, for instance, whether you start banking or not because you start banking, or in your taste for media outlets, or your transmission of information and your interpretation of the news, and so forth. And there could be consumer tastes that could diffuse, health-related phenomena such as smoking cessation or depression in other work that we are doing. So the availability of this kind of data is increasing and will continue to increase. As Gary has already highlighted some of these ways in which we live in an environment of pervasive data, reflecting internet information that's being collected all the time, websites, query logs, links, and so forth, telephony, video cameras in cities, RFID devices. So clothing now, when you buy from a store, would have these little tiny devices. Well, maybe it'll just stay on the device until you go home. And maybe your computer will just monitor the inventory of all the clothes in your house. And now that's digitized, and that can, of course, then be uploaded and analyzed by other individuals. Administrative records, emergency room visits, crimes, toll transactions, transaction records, financial transaction records, geographic information, and a very interesting development that most of you are quite familiar with, voluntary losses of anonymity with data wikis. I was talking to one of my postdocs recently who told me that he's applying for jobs. Maybe all of you guys know this, but I asked him, he was aware of the fact that who had been inviting who for interviews and making offers, where anonymous collectives self-organize on the internet and post information about have they or have they not received invitations for interviews or been offered jobs. So everyone else can go to this wiki and see. Here's the Berkeley Sociology Search for this year data wiki, and we can see what's happening in real time. Many other voluntary losses of anonymity. Gary alluded to some blogs and the like. And of course, personal genetics, which no doubt in the next 5 or 10 years, we will have people that have increasing information about their own genetic makeup, which may be made more generally available. So, and we'll be increasingly in the situation to obtain this passive surveillance in real time. Well, what are some of the challenges that all this poses? First of all, in visualization and heuristics. No doubt, and Sandy presented some stuff I think that is incredibly important in that regard. Data management and reduction. I mean, the volume is now overwhelming. It's like trying to drink from a fire hose. Causal inference and new statistical tools. Gary alluded to some of them. We're struggling with some others. The issue of whether the projects are being data-driven or hypothesis-driven. And I think this is a very interesting area. I think my sense is the following. Just like there was a transition, IBM thought that the hardware was valuable and the software was irrelevant, and they were wrong, and Bill Gates has billions now. I think we're changing. We're in an era now where things are changing. It used to be that the analysts, the academics who knew how to analyze data, regarded the availability of data as a commodity. And the commodity providers were of second order. And the data analysts were the primary ones. But I think the power is shifting now to the people who own the data, who will come to look at us as, well, we could have you analyze our data, Christakis, but actually no, we'll just have someone else analyze our data or have it in-house ourselves. And so I think because of the sophistication of the data that's available, its volume and its rarity and its utility, I think we're going to begin to see some shifts. But paralleling with those shifts will be people who analyze data because they have the data versus people who have questions they want to ask and then go looking for the data to analyze it. I think maintaining the balance between observation and theory is going to be quite important. I think doing social science experiments in the new world, Gary alluded to the one in Mexico, but others, Damon Santola and I are working on some projects to look at how we could use these kind of passive, massive, internet-based data collection efforts and actually experiment in that world. I think another challenge posed by this kind of complexity in social science data is interdisciplinarity, data security, which has been alluded to, and most important, what are we going to do with the data? I mean, is it just a wonderful toy that we have? And right now we're in this exciting moment where we can draw all these pictures and grab all the low-hanging fruit off the trees, or do we have a research agenda? For me, I think that the important research questions in this area, the big intellectual questions, have to do with the origin of behaviors and values and norms. Where do these things come from? No doubt they're partly genetic, but they're also socially constructed. How can we use these data to understand the origin of these fundamental things? What are the origins of social structure and collective action? A very ancient problem, but one we're still very interested in. How do groups come to be organized? The origin, and finally, the super-individual, institutional, and structural constraints on individual action. Can we use these kind of data to understand how it is that you can move between the individual and the collective level of understanding? Now, similar problems, of course, are being faced in bioinformatics, and along with Laszlo, for example, we're studying a database of 12 million patients who have 32 million hospitalizations, each time of which they could have up to 10 diagnoses, drawn from a set of 10,000 unique diagnoses, and every one of these hospitalizations can occur at a particular moment in time across a 10-year period. So good luck to us to try to figure out what's going on in all these data. We have some ideas, and of course, very analogous problems obtained with genes. You've got 25,000 genes, which are expressed at different moments in time, in different individuals, and so forth and so on. So my last slide, I think it's important to understand that more careful and more complete observations are great, but what are they in the service of? Will data collection in its breadth and detail prove to be like the data that Tycho Brahe had and was analyzed by Kepler? Or will it be a distracting profusion of noise? And in 1563, when he was 17, Tycho said the following: I've studied all available charts of the planets and stars, and none of them match the others. There are just as many measurements and methods as there are astronomers, and all of them disagree. What's needed is a long-term project with the aim of mapping the heavens, conducted from a single location over a period of several years. Thank you.
Let this be that location. I think we're going to take questions. Is that right?
Yeah.
So I think we have around 10 minutes for questions. And so,
Who's that?
So you made a point about data as commodity, and it's sort of intriguing to think, on the one hand, we're getting lots of data from lots of new sources, but then the people who own this data are going to be able to choose the analysts who come to it. And I wonder if that's actually true. If there's going to be so much data available that actually the market will work in reverse and put the power back in the hands of the analysts, because if they can't get the telephone data, they'll go get the internet data. If they can get the internet data, they'll get the email data.
I don't know. I can't predict which way it's going to happen, but I sense a little subtle shift in people like financial organizations and other corporations that have lots of data, or government agencies that have lots of data, which of course operate under different constraints, in their attitude towards the value of the data. So even in my career, 10 or 15 years ago, I would go to organizations and say, can I have some of your data, which you're not using anyway? You just regard it as administrative data, but I have some interesting social science questions. And they said, oh, sure, go ahead. And they didn't see it as much value. But I think now they're seeing that there is value in their data and that they shouldn't willy-nilly just give it to anyone who asks. and that as a result, they're having in-house analysts who aren't, to be blunt, I think as sophisticated oftentimes as we are, but who nevertheless, it's good enough for them. And if they contract with us to release the data, they have a kind of different power position, I think, than they did. I don't know how it's all going to play out, but I sense a little bit of a change in this.
So, James, I think you're right, and your distinguished co-author is wrong.
That's what we need to adjudicate all our disputes. Can we call you in the middle of the night now?
I think Nicholas is right in the sense that if you ask somebody for data and they have it and you don't have it, then they control something that you want and they have power over you. But I think the bigger picture is that it used to be that information was really expensive and it really had a lot of value and you would pay a lot for information. Now information is free. What's expensive is meaning. Right? So you can get information. It's just pouring in. Just hook up to the internet. And there's so much information you don't know what to do with. If you can explain what to do with, that's valuable.
No.
Right? So the statisticians will rule the world in some sense. The analysts.
Disinterested point of view.
Just totally disinterested. That's right.
Yeah. Seeing. I mean, I'm not trying to suggest that sort of kind of mindless. I'm not by any stretch of the imagination defending the idea that mindless data mining is the appropriate thing to do. I'm just trying to point out the fact that that these data are, while massive and huge, are regarded as valuable by the people who own them because we've taught them that if there's something cool that can be done with it. And I think that, as I said, discerning the signal from the noise is still a huge challenge, and I think we do obviously have expertise in that area. Yeah, Laszlo.
Anyway, so Gary, I have a question to you actually. You mentioned that we have no idea how to analyze, for example, the cases of humans using statistical methods. And I fully tend to agree with you. I would even go further and I would say the very existence of statistical methods is a problem for the field because there are people who think they can use the standard methods to analyze them. And there are killing publications and everything as you're trying to push on them the traditional methods that were kind of developed for completely different reasons.
Right.
So how to change that? Really? I mean, like, how are we going to have to wait until the statistical community comes around and looks at these data sets on their own terms and not simply trying to take their own acts to work that?
Yeah, I think in some sense I should answer all questions the way I did the previous one. The statisticians, I'll change it. The statisticians should rule the world. No, but I think you're absolutely right. People will often say, the data are not that good. And actually, as an aside, no matter how good the data are not that good because we're always pushing the edge of the envelope. Okay, so it doesn't matter how many observations you have. Have you noticed that all t-statistics in all journals are around 2? I mean, plus or minus 3. They're never 150, right? And the reason why is because if you have 27 million observations, you just break it up into enough categories so that it's 2, right? Right. The value of the t-statistic is what you condition on. It's not a finding. But in any event, people often say the data are not good enough. They don't admit to fancy new statistical methods that you have to develop specially for them. Instead, we have to use off-the-shelf methods, and that's actually the opposite of the truth. Okay, the only reason you need sophisticated methods is to deal with the problems in the data. If you have screamingly clear relationships and data with no error, which probably wasn't created by humans, of course, right? Then you don't need complicated statistical methods. So I totally agree. David.
Okay. So I'm, of course, highly sympathetic to your thoughts on O'Brien. But if it's just your volume, I mean, you've had the stock market for a long time. There's a tremendous amount of data coming from that. You haven't been able to make systematic sense of it. So it's not just volume. It's something, the underlying regularity of the system. And that's what the plan is for, this ridiculously well-behaved natural experiment. I guess my thought is, do you think there's anything that well-behaved on the internet? So the volume of data gives us some underlying traction.
I'm glad he asked you.
No, he asked you. You're the one that talked about volume of the internet.
Some yes, some no. We're going to have to find that out. Right? I think we're going to.
David and I talk about this all the time. I mean, I'm an eternal optimist in this regard. I mean, I think there are really profound regularities in the social world. The question is, are there regularities which we have not yet discerned? Or are we just finding more sophisticated ways of confirming what we already know, which goes back to Gary's point of, I'm going to study this, and then I'm going to study that, and I'm going to study that. I mean, can we identify real phenomena like the planets, which weren't visible until we had this data?
I mean, that's right. The thing about that data set is that, starting with Ptolemy, who we're working on it, and of course the refinement increased, of course, with Tycho Brahe historically, but the fact that everyone agreed that there was one data set that we need to understand, it would be nice if we all agreed there was one data set we need to understand.
The Tycho Brahe thing, Damon, was a metaphor.
Let's suppose you're interested in crime, okay? And let's suppose you're interested in crime, and you have the number of crimes or murders or whatever it is at the end of every month, okay? Maybe even at the end of every month for every city. You could run some nice regressions, okay? But then if you knew where every crime was geocoded to exactly the time and the place, maybe you won't be able to fix this problem, but you ought to be able to make a heck of a lot more progress. Larry.
So, Nick, I was struck by the questions you listed at the end of your talk, and by their proximity to the questions that the inventors of survey methods were trying to answer in the 1920s and 30s. And so this is a variant of the other question, of the earlier question, which is really to say, if we look at other sciences, do you think they've made more progress than we have? Or are they still asking the same questions?
I mean, I just listed some of the things that are of profound interest to me and other social scientists. Are there new questions we could ask? I mean, I suppose it depends on how you define what is a question. So is the question, what is the order of the solar system? And we're still working on that thousands of years later. Right now we're finding new moons around these we're renaming Pluto. We find what the surface of these planets are like. We send probes on it. Is that the same question we were asking, when Tycho was doing his observations, or is that a different question? And so therefore in the social sciences, so Plato's concerned with social order, and we're still concerned with social order over 2,000 years later. Are we asking the same question that Plato asked, or are we asking different questions? And so, I think
Social values.
again, a very old question.
Very old question.
Right. But is it the same or is it different? I don't know. I mean, I think to answer your question, it would depend on what we mean by that.
I think given the resources and given the difficulty of the problem, we're not making any worse or faster progress than anybody else. I mean, imagine astronomy, where imagine astronomy in a universe in which every time you looked at a planet, it pulled up its atmosphere. So you couldn't look at it, right? Or atoms, when you looked at bacteria under the microscope, they took offense, right? I mean, you can imagine these things. So Heisenberg's uncertainty principle is a very nice thing, but it's just not even close to the kinds of things we have to deal with. I mean, as you know better than anybody. So we could do better, but we're going to need a lot more help than physics and chemistry.
Yeah, apropos, actually, I think that there's also some huge advantages that we have working with people, and the analogy of astronomy or looking at atoms is useful. But I think that one big difference is that there's an opportunity to do some experiments you can't do in astronomy. And you mentioned that briefly at the point, but I think that the total raw quantity of data isn't. You can get very high peaks. That isn't really going to ultimately resolve the causality issues very well. No matter what kind of statistical techniques you put at it. But there's another missing ingredient, which is that in many cases, I think organizations are willing to do not just natural experiments, but real experiments, and I think that's becoming more and more common, certainly in marketing, but also in other areas, where companies see the power of this and are willing to modify when they roll out technologies, or what kinds of programs they offer people, or other kinds of interventions. And then when you combine that with this kind of detailed observation, you can get a much better chance of disentangling the causal issue. I mean, a lot of the examples you gave, if you're a skeptic, you can think of, well, maybe there's some other third variable that's actually causing both those things. So it's not that obesity is transmitted socially. Maybe they both watch the same commercials, or a new McDonald's opened, or whatever. But if you can do experiments, then you can address those questions much more. So I think that's an opportunity that we're also right on the verge of.
Yeah, I think that's an excellent point. It used to be that in the social sciences, we worried that we were part of the society that we were studying, but actually now that we know how to study it, the fact that we're part of it is really a valuable thing. Yeah, that's right.
It's not a bug, it's a feature.
Yeah. I think there was somebody. Yeah.
I have a question, slightly more cautionary tone. I was struck by your comment that you find sort of human subject issues, interesting, challenging, but not particularly difficult in the scope of things. And I just see it very differently. I wondered, the idea that you do a network study in an organization, and if I'm asked, do you want to participate, and I say, no, I'd rather not, and everybody else nominates me as the least trustworthy, least knowledgeable, most, least energizing person, it's fundamentally different, I think, than a survey where you say, I'm not going to fill out the survey, I'm out. Now, you can design a survey that would pick it, those people that are out, but typically if you say, I'm out, I'm out. I can't opt out of a massive data collection effort by the government to track phone records or whatever else they're doing. So I just feel like it's a very different world than that, and I wonder, we're going to get to this later, but I just wonder if you could say a little more about why you had that, or why you took that.
Yeah, by easy, I only mean that it's not going to stop us. It's going to stop us in lots of specific areas, as well it should. But it's not going to stop. It's not going to stop the enormous progress that's about to happen, and that's happening. So, and I don't mean it's easy. And I think whole fields will pop up that do nothing but figure out privacy. I mean, there already exist fields about how to, how to cripple data or not distribute some information but distribute others. And IRBs are rising up to protect us. And so this is not a minor matter. I mean, I think there'll be people who do nothing their entire career but try to figure it out. But it should not stop us. It should not stop us. I mean, often people completely outside our field, when they ask what we do, and if I give a little talk like this, that's the first word out of their mouths is privacy. And it's like, well, you can't do that. You can't look at. Well, yeah, actually, you know what they do in every other area. We could do it too. And there's proper ways of doing that. We can figure out what those are. We can apply them to brand new areas, and we can deal with the problems just like the ones you're talking about and other kinds of things, and figure out how not to harm research subjects. But actually, we're going to benefit research subjects more than any research has ever benefited or had any effect on research subjects. I mean, we're going to be able to solve problems that humans face. I mean, it's just going to be really valuable. It's an important problem to tackle. So.
Is your concern, I mean, there are two people who express that concern often have two different concerns at different levels. So there are the individuals who worry about their actual anonymity. And that's a problem that I think can be dealt with fairly, just like the IRS has procedures for not releasing its tax records and fires employees or puts them in prison if they go looking through Schwarzenegger's files. There are procedures that protect the anonymity of an individual, and all of us willy-nilly file our taxes and send them to the government. And I have good confidence that my tax records are not going to wind up visible for everyone to see on the internet. But there are other individuals who take it to a next level, and they are so spooked by the kinds of stuff that we're talking about that they really want to get off the grid altogether. And I have one graduate student in my group who actually have two. I have two that have no Facebook pages because they just don't want to leave a trace. And one has no Facebook page and actually has no electronic, doesn't use credit cards. He's a freak. I love him to pieces, but he's weird this way. And and so that's a whole other level of this guy worrying that he gets phones from those disposable phones you buy because he doesn't want Laszlo or Gary to know what is. But Laszlo or Gary don't really care, right? I mean, they just look at millions of records. I mean, I am not drilling down to see. And this comes up in our work. We have the healthcare records of all 32 million elderly Americans. I know every single doctor visit and every single hospitalization for every one of these people for an amount of time that would blow your mind. But I don't actually care who these people are, right? I have no interest in drilling down to this Mr. Jones and finding out who he is. But maybe that Mr. Jones would care and wouldn't want to be even discernible.
We need to break now for a few minutes.